Approximating areas is something we do all the time in calculus. Now, in geometry and pre-cal, you could find the areas of rectangles and triangles quite simply. But if I wanted to approximate a circle before I knew that the area is pi r squared, so if I wanted to do it before I knew that, then I could just divide it into different segments and approximate using those triangles. So we're going to do something similar for approximating the area of a bound region between x equals 0, x equals 2, and y equals 0. So we're looking at this region right here. Now, we're going to divide this region into 5 equal areas. So in this case, n is going to equal 5. So the first thing I need to find is delta x. And delta x is always going to be b minus a divided by n. b in this case is 2, and a is 0, and n is 5. So this is 2 minus 0 divided by 5, or 2/5. So each rectangle that I have has a width of 2/5. Now, where is each rectangle located? Well, x of I is going to be, we have to look at where we start. So that's going to be A plus. Now, if I'm over 1, it's going to be at 1 times 2/5. If I'm over 2, it's going to be 2 times 2/5. So it's over at I delta x. So this is how we locate each x of I. Now the third thing you need to know is the height of the rectangle. Now how tall is any given rectangle? Well, in this case, I'm going to evaluate it at x of I. So the height of my rectangle is a function evaluated at x of I. So for this case, this is my function. It's minus x of I squared plus 5. Now remember, what is x of I? X of I in this case is a plus I delta x squared plus 5. Now in this case, a is 0, so this is minus I delta x squared plus 5. So, what is the area of each rectangle? So the area, oops, let me change pen colors here. The area of any individual rectangle is the height, f, at x of I times the width. So I'm just going to call this delta x of I, even though they're all the same. So each function evaluated x of I is going to be what? Minus I delta x squared plus 5 times delta x of I. Now the beauty here is delta x of I is always 2/5 for these. So I'm going to quit writing that. So I have each area. So the total approximated area is the sum as I goes from 1 to n, or to 5 in this case, of f evaluated at x of I times delta x of I. So this is the sum as I goes from 1 to 5. Function evaluated at x of I is minus I. Now, what it was delta x, remember delta x is 2/5 times 2 divided by 5 squared plus 5, all times 2/5. So this comes straight down. So this area is equal to the sum as I goes from 1 to 5, and I'm just going to multiply this out. All right, so this becomes minus 2 cubed divided by 5 cubed times I squared, that's my first term, plus 2 fifths times 5 is just 5. And if I do this sum, I get 162 divided by 25. So this is about 6.48.